All right, hey folks, just want to kind of walk you through this next section here. I know I say that every time, I'm sorry. But I want to look at 2.6, proving angle relationships. And going to kind of show you some theorems, going to talk about how to prove those theorems, and then I'll walk you through a couple of the problems that are actually on the worksheet here. I do want to see these notes when we come to class on the next day. Okay, so as we take a look, I'm going to get rid of my ugly mug and go right to the notes here. So we're working in 2.6 here, and I'm going to go quickly through this because I don't want this to last real long. Feel free to stop, pause, and rewind if there's some parts that you don't quite understand. So the first one after the topic is called the angle addition postulate. And the angle addition postulate we have studied already, where if we take an angle here and we add in another angle here, it's going to equal the entire angle that we have. So again, ADB, angle ADB, angle BDC. If we add those two together, what we get is angle ADC. Okay, so angle addition postulate. Not meant to be hard to remember. It's something that I think we should all probably memorize along with the segment addition postulate. Okay. Now, these next couple theorems are going to be important for this chapter, but as far as I'm just thinking long term, it's important to know what they mean or how to apply them, but as far as memorizing them, I'm not sure that's necessary. I think you should automatically memorize them as we work through these next couple of days and practice problems involving them. So here's what we have. We have what's called the supplements theorem, and it reads this. If two angles form a linear pair, now what is a linear pair? Remember, it's a pair of angles that form a straight line, adjacent pair of angles that form a straight line. So as you look here, I went in and drew that out. I've got a linear pair between two angles. Then they are supplementary. Well, you already knew that, right? You already knew that they were going to be supplementary because they formed a straight line, okay? But whenever you see this, I need you to be thinking 180 degrees, okay? That is called the supplements theorem. The complements theorem, the next one, says this. If the non-common sides of two angles form a right angle, okay? So the non-common side, the common side would be this one right here. The non-common would be this one here and this one here. If those two sides form a right angle, which in my picture they do, then the angles are complementary angles. So the two angles that make up that right angle have to be complementary, okay? So again, whenever I show you a picture like this, I expect you to be able to set up an equation like that and solve for 90 there, or solve for an angle measurement. All right, the next one, I was a little off the screen there, I'm sorry. Okay, so hopefully that made sense. Again, the non-common sides would be this one here and this one here. Okay, the common side is that one right there. The next theorem is called the congruent supplements theorem. Okay, and that says angles supplementary to the same angle or congruent angles are congruent. Okay, and so if I look at this, I drew a picture out here. Angles 1 and 2. And 2 and 3 are supplementary. Okay, they add up to 180. You can kind of see these two. If I was to slide them together, you would have a straight line and have supplementary angles. So again, if we have two angles, 1 and 3, that are supplementary to the same angle, okay, or congruent angles, then they are congruent. Okay, so they're saying that angles 1 and 3 have to be congruent. So there's several ways we can take a look at this. One way would be to actually go ahead and do a little proof, okay? And what I'm thinking is this. If I've set up the initial equation, okay, the 1 and 2 are supplementary and 2 and 3 are supplementary, I then can go ahead and do something like this. Angle 1 plus angle 2 equals angle 2 plus angle 3, okay? Now, what's that called? Well, that's called substitution. What I'm doing basically, since both these equal 180, I can take this and plug it in for that right there. And again, that's substitution. Or substitution property, either way. Now from there, if I subtract angle 2 from both sides, what we then know is that angle 1 and angle 3 are the same measure, or they are congruent. Okay? So, and what am I doing there? This would be the subtraction property of equality. Okay, So again, as I look at this, if you have two angles, 1 and 3, that are supplementary to the same angle, then 1 and 3 have to be congruent. Okay, so congruent supplements theorem. So the next theorem is what's called the congruent complements theorem. Okay, and if we look here, the congruent complements theorem is very similar to the congruent supplements theorem. So angles complementary to the same angle or congruent angles are congruent. So if I was to draw a picture out of this, if you're struggling to pick up on what's being said here, okay, let's say that again, angles that are complementary to the same angle. So let's say 1 and 2 are complementary. I've already shown that there. But let's also say 2 and 3 are complementary. Okay? Then if that's the case, then the angles are congruent. 1 and 3 have to be the same. I could go ahead and do something like this. If this is 60 and this is 30 to make 90, if this is 30, then this has to be 60 to make 90. And what we see is that those two have to be the same measure. Okay? This last theorem might be the absolute most important theorem in the packet or in this section that we're going to look at, because it's going to be used quite often, okay, and throughout the rest of the year. So it says this: if two angles are vertical angles, then they are congruent. Okay, now we already proved this earlier this year, but I'm going to do it in a little bit different way. I'm going to go ahead and say something like this: angle 1 plus angle 2 equals 180. And angle 2 plus angle 3 equals 180, okay? Again, 2 and 3 make this straight line, 1 and 2 make this straight line, okay? Now, as I look back, the supplements theorem says this: if two angles form a linear pair, then they are supplementary, okay? So I'm going to go ahead and say this. I came up with this equation because of the supplements theorem. Okay, I could say given, but we really weren't given that. We were given the fact that we had vertical angles, or that the lines were intersecting. Okay, but yeah, this is a linear pair between 1 and 2, and this is a linear pair between 2 and 3. Okay, now I'm right back into the mode that we did before. If I go ahead and add together 1 and 2 and angles 2 and 3, they have to be equal because they're both equal to 180. So I'm going to say substitution for that one as well. Substitution property. Okay. And then if we subtract angle 2 from both sides, 1 has to be equal to 3. Okay. Equality. Okay. So hopefully you understand that 1 and 3 will always be congruent no matter what happens, and 2 and 4 will also always be congruent no matter what happens, okay? Now, I want to show you something else here. If you turn in your textbook to page 163, you have a couple of theorems there at the bottom of that page that I'm not really going to go over. These are things that you should already know. And so perpendicular lines intersect to form right angles. We've talked about that quite a bit. All right angles are congruent. If you didn't know that, all right angles were 90 degrees, therefore they are all congruent. Okay? The next one says this: perpendicular lines form congruent adjacent angles. Okay? So if you struggle with 211, here's what's going on with 211. If I were to go ahead and do something like this: perpendicular lines make congruent adjacent angles. So they're perpendicular, so it's right angle. So from here, if this is a right angle, this is also a right angle because they're a linear pair. And so if it's 180, I need 90 and 90. So make congruent adjacent angles. Congruent adjacent angles. Congruent adjacent angles. And congruent adjacent angles. Okay? So all those are 90. They're all congruent and adjacent. Okay. 212 says this: if two angles are congruent and supplementary, then each angle is a right angle, okay? So if these two are both congruent and supplementary, they both have to be 90 degrees in order to be supplementary and congruent, okay? If two congruent angles form a linear pair, then they are right angles. So if these two angles are congruent and they form a linear pair, they have to be right angles, okay? So I would assume that most of those are straightforward. They don't, require a whole lot of other information. And so I'm going to pull out the worksheet here, the packet, and kind of talk you through some things. First of all, notice the different theorems. You can feel free to read through those, make sure you fully understand them. And, I've already explained them fairly well, I think. And so you can double check your understanding by looking through those. And you can look at those first two examples there. I'm not going to. I'm going to get into a couple of these problems here just to make sure that we are good. And let's do number one here. Yeah, let's do number one, okay? So it says this: find the measure of each numbered angle and name the theorem that justifies your work, okay? So when I look at this, measures 7 and 8, the measure of angle 7 and measure of angle 8, I know that they're not equal. 7 is quite a bit bigger than 8. It's very obtuse. So the next thing I'm thinking is, hey, this is a straight line. Well, that makes these a linear pair. And if they're a linear pair, then what do I know about them? That their sum has to be equal to 180. Okay? So I'm going to go ahead and put down that this was the supplements theorem. Okay? And then I'm going to substitute in what we have here. So the measure of angle 7 is 5x plus 5, x minus 5, 6x. The 5s are going to cancel out. Positive and a negative cancel each other out. And if I divide through by 6, x will equal 30. Okay? Now you might be thinking to yourself, Mr. Couples, you didn't put down the reasons like they did up here in the example. Okay? Well, I'm not worried about that part right now. We can practice that later, but right now, make sure you have supplements theorem there. Okay? Now, if I want to figure out, let's see here, find the measure of each numbered angle, and then the theorem that justifies work. So if I go ahead and plug this in, I can find the measure of each measured angle. So angle 7 is going to be 5 times 30, 150, plus 5, 155 degrees. Pretty big angle, pretty obtuse. If I plug in 30 here, for angle 8, 30 minus 5 is 25. Okay, which makes sense with my picture there. Okay. So, sorry, get that off. Let's move to another part of the packet here. Okay. As I look down here at the different theorems, you've got just the list of theorems that we already talked about, that we proved somewhat. Some of them, I should say. And so what I'm going to do next is take a look at this proof down here. Okay. So we're starting to remove our numbers, and we're getting to more terms, and so we want to make sure that we understand what's going on. Excuse me. Friday afternoon blast. All right, so here's what we have. Given ABC and angle CBD are complementary. So this angle right here is 90 degrees. I'm actually going to go ahead and show that there. Then I have angle DBE and angle CBD form a right angle. So these are also going to form a right angle, those two. Okay. Now, from here it says the complements theorem. The complements theorem. So angle DBE and angle CBD are complementary, and this is true. Because they form a right angle right there, they have to be complementary. Okay. Now from there it says angle ABC and angle DBE are congruent. Okay. So here's what it reads. The congruent complements theorem says this: angles complementary to the same angle. Okay, so angle ABC was complementary to angle CBD, and angle EBD was complementary to angle DBC. Okay, so angles complementary to the same angle or congruent angles are congruent, and that is true. Okay. All right, now I'm gonna pick one of these two to work out with you, and then I'll let you guys go ahead and pick the other one to finish up. So as I look at, let's just look at number 2 here. It says angles 1 and 2 form a linear pair. Okay, so I should be thinking what? I should be thinking 180 degrees. Angles 1 and 3 add up to 180. So these two right here also add up to 180. Okay. So we've got the given here. The supplements theorem says that if we have a linear pair, then we have two angles that add up to 180. So I'm going to put angle 1, measure of angle 1, plus the measure of angle 2 equals 180. Okay. We know that angle 1 and angle 3 are supplementary. Okay. So I'll just put definition of supplementary. Okay, and then from there, oh, I think I just realized something I should have done. Since this is the supplements theorem, instead of writing it out as if angle 1 plus angle 2 equals 180, let's do it this way, just to fall in line with what's happening here. Angle 1 is supplementary to angle 2. Okay. Now, if angle 1 is supplementary to angle 2, and angle 1 is supplementary to angle 3, what do we know about 2 and 3? Okay, well, let's put some numbers to this. If this is 40 degrees and this is 50, because they're, 40 degrees, this is 140, because they're supplementary. If this is 40 degrees, this is also 140. So what do we know about angles 2 and 3? Well, they are congruent. Okay. Angles supplementary to the same angle or congruent angles are congruent. Anyways, I hope that was understandable. If you have questions, obviously come back and talk to me, but see if you can do that first proof for me, and we'll take a look at it when we come back to class. Thank you. Have a good day.